let's look at how we can apply the sine rule. We're going to look at an example. If you check out ECZ Mathematics paper 2 of 2019, you'll be asked to find the length in a quite different way. But basically, if you follow me through this example, you will be comfortable, maybe even better, at finding distances or lengths using the sine rule. Since we've been asked to find missing lengths, we've been asked to find the length BC and the length AC. For us to be able to use the sine rule, we need one complete ratio, and then we use that complete ratio to find a way of completing the other ratio. Now, if we look in this question, we don't have any complete ratio. By complete ratio, I mean we should have an angle and its opposite side. As you can see, this 40 doesn't have its opposite side. This 275 kilometers doesn't have its opposite angle. So it's like, how can we find this? But actually, we just need to do some thinking here. If we've got two angles in this triangle, which are the interior angles, 125 and 40 degrees, we can find the remaining angle because we know the sum of the interior angles of a triangle is equal to 180 degrees. Therefore, it's like we'll give this angle here that we don't know a value of x degrees, and we form a simple equation. 125 plus 40 plus x is equal to 180. We add these two just for preventing any mistakes that you might make, that the sum of these two numbers is 165. You can pause the video if I was too fast, but I'm sure you did that too very quickly. Then we are going to get this 165, take it over to this part where we've got the 180. Simply you are doing what we call in mathematics collecting the like terms. All the numbers go on one side and all the letters go on one side. We know we only have one x here. One other thing you can do is just simply say that we are subtracting 165 on both sides. So 165 minus 165 here gives us a 0, and then 180 minus 165 is giving us the value of x. If we find the value of x, it will be 15 degrees, and it's quite a good practice you labeling what you found. We have the value of 15 and I've indicated it here in blue. When you're writing in your exam, you can do that in pencil. Okay, now we have a complete ratio, this angle to its opposite side. Before we can do anything, let us label our opposite sides so that we don't take any risks. Sometimes pupils tend to forget which one is their opposite side, and it makes them get questions wrong even when they know the concept of using the sine rule. This is A, so this will be our opposite side and we'll make it have small letter A. This is B here and it will have small letter B. This is C and it will have small letter C. Now we state the sine rule, two ratios at a time. One of them should be known, so obviously we're going to have sine C over C, and let's start with the first one. We go in alphabetical order, so sine A over A. Now one thing you can do is just plug in your values. You know we're finding A, so there'll be nothing. We've got 125 degrees for the value of A. For C we've got 15, and then for distance C we have 275. By the time you're doing the sine rule, you should know how to make the subject of the formula. So it's best that you just make this A the subject of the formula. You cross multiply and then have an equation C sine A, and then this A multiplied by that gives you A sine C. And to make this A the subject of the formula, we're going to divide both sides by sine C, and this sine C will cancel with the sine C in the denominator, and we have A as our subject. There's no need of me writing this whole step once again to just show I've made it the subject of the formula. I know that A will be equal to this part here, so I just get the value for C, which is 275, and multiply it by sine 125. And then we have the sine C here. C is 15, so we just put it there. It's time now we grab a calculator. I hope you came with yours. If you didn't, pause the video and get one so that this process can be easily remembered. One thing I like is writing my sines first. So I'm going to find the value of sine 125 first. Make sure your calculator is in degrees. It should show some D in your display on top here. If you don't do it right, it might give you some wrong answers. You might not know what's happening. Okay, so this is the value for sine 125. Then I'm going to multiply it by 275. You notice that immediately I say multiplication, my calculator knows I want to multiply the answer by 275. I hit equals, that's my answer. I'm just going to get some values from this. I'll leave this answer on the calculator for use later. So 2252668, we end on that 8. Okay, so A is equal to our answer that we had on our calculator. I hope you wrote it somewhere. It was 225.2668. If you didn't, then we also find the value of sine 15. So I'll get sine 15 like that. And yeah, right now I get this here, punch it into a calculator, and I find the value of A. Now, one thing you'll find is that if you punch in these numbers, obviously I've taken enough figures, my answer won't be affected. But if I take two little figures, for example, I take 225 divided by 0.25, my answer might differ just a bit. So one practice I like teaching people is you just get your values. Remember we said it was sine 125. I hit equals, then get that, multiply it by 275. That's my answer. My calculator has the power of storing this answer, so I use that power of my calculator. I just hit division, then whatever I want to be in my denominator, I just insert it. So sine 15. Notice that my calculator here put a bracket, so I need to close the bracket for this operation of sine. Then there was another one here, I close. I hit equals, and it gives me the accurate answer. This answer has no errors, I'm telling you, because we calculated it on the calculator. It might not differ much from the answer you get if you divide these numbers, because I tried as much to get enough digits so that the answer does not change even if you calculate using these numbers. As you saw, A was 870.36. We just take 3 digits from this number, we round off these 3 here, and A will be equal to 870 kilometers. Now, your job is to try to work out the value of B. It's actually simple. We're doing the same thing. We need to use one of the ratios that we know. If you want to be a bit experimental, you can even try using this 870 and the 125 to find B. But I'll advise you to use the angles that you've been given in the question. So just use sine C and this 275 to find the B. If you get it correct, give yourself a pat on the back. So we're making B the subject of the formula here. After we make B the subject of the formula, then we just substitute. And again, we punch in our numbers. For the examiner to see our numbers, we punch them separately, then come and punch them together, and we find our answer. Make sure you always show this answer that is not rounded off, and then round it off to 3 significant figures in this case, and you have your answer. You have finally reached the bonus tips section. Today we've got 2 tips for you. The first is the difference between an obtuse triangle and a scalene triangle. You might think they are the same, but nope. They might look the same sometimes, but they are different. An obtuse triangle will be different from a scalene triangle because an obtuse triangle always involves an obtuse angle, while sometimes a scalene triangle might not even include an obtuse triangle. Right now you might be asking yourself, what is an obtuse angle? Well, this is just an angle that is greater than 90 degrees but less than 180 degrees. If the angle is greater than 180 degrees but less than 360, we call that angle a reflex angle. Another thing that differentiates these two triangles is that sometimes an obtuse triangle might be also an isosceles triangle, but for the scalene triangle you can never find a scalene triangle that is isosceles. Why? If you can remember what we covered under the introduction to trigonometry, a scalene triangle is a triangle that has all its sides different in length. Tip 2 is about how to use the sine rule to find angles. I'm sure you know the sine rule by now. Sine A over A is equal to sine C over C, or we can also use sine A over A is equal to sine B over B. Now, the angle part of the sine rule is this part where we have our capital letters or uppercase letters. In this question, I want you to find the value of A. What you will notice is that this triangle has been used in this video, and if you are very observant, you know the answers for each of these parts. But I don't want you to just know the answer. I want you to calculate the answer for this angle here using the sine rule. What you're just supposed to do is this simple thing. You get this formula here, or the sine rule, and then make A the subject of the formula. We do that by cross multiplying here. Then we have an equation, C sine A is equal to A sine C. After we have that, we divide both sides by C to get rid of the C here that is combined with our A. As you can see, the C and the C cancel out, because if we have C in our numerator and C in our denominator, that C is actually doing nothing. Now, what remains is getting rid of this sign. By principles of mathematics, you know that if you want to get rid of something, we divide by that thing. Now, in mathematics, we cannot divide by sign only. So what we're going to do is just get rid of this sign here, and then on this other side of the equal sign, we're going to introduce sine inverse, just like we did when we were handling the trigonometric functions. So A will be equal to sine inverse this fraction we have here, which is A sine C over C. With this formula, you'll be able to find the angle for A. What I want you to do is also find the angle B using the sine rule. Thanks for watching till the end of this video. This triangle I used is exactly the same triangle that was used in the example. So if you want to know the answers, just get that triangle. Your answers will be the same answers for this simple exercise at the end.